मैं राकेश कुमार असवाल, सीनियर लेक्चर, गवर्नमेंट पॉलिटेक्निक कॉलेज जयपुर, सिविल डिपार्टमेंट। स्टूडेंट्स, आज मैं आपको कैंटिलीवर बीम सब्जेक्टेड टू पॉइंट लोड, ये आज आपको मैं समझाऊंगा। ये कैंटिलीवर बीम है। कैंटिलीवर बीम जैसा मैंने पहले बताया था आपको उसके बारे में कि सपोर्ट इज फिक्स सपोर्ट and the other end, one end is fixed support and other end is free. That type of beam is called cantilever beam. And today we are going to study about this cantilever beam when it is subjected to point load. पॉइंट लोड कितना है, लेंथ कितनी है कैंटिलीवर बीम की, एल लेंथ है। और एल लेंथ पे एंड पे, फ्री एंड पे कैपिटल डब्ल्यू एक ही पॉइंट लोड लग रहा है इस पे। कहाँ पे? बी पे। ये तो हमारी प्रॉब्लम हो गई। अब अपने को इसका शेयर फोर्स डायग्राम एंड बेंडिंग मोमेंट डायग्राम दोनों बनाने हैं। जैसा we have already studied that first of all we draw sign convention. This is sign convention. Shear force, this is section, dotted line is section. Shear force upward left side, downward right side would be taken as negative. Bending moment clockwise left side and anti-clockwise right side would be taken as negative about the section. So shear force, now we want to calculate first the values of shear forces and then we draw the shear force diagram. Second part, first part is sign convention, second part is calculation the value of reaction. Reaction means support. The load which is coming on the beam is supported by how much supports? Here only one support is there because the one end is free and one end is fixed. So there is no support. Here is support only. So the reaction is RA at A. This is the only support which carrying this load, which supporting this load W. So we can say that only RA is there. So RA, this is upward support. This would be equal to the total load coming on the beam, and which is W, capital W. Only one load is there, so total load is equal to, but here is one load is there, that's why R is capital W. Then the value of reaction RA value. Now after calculating the values of reaction, the all forces we have got. Now draw the shear force diagram. In case of cantilever, we try to always, or we can say we should always start from free end B. Of in case of cantilever, हमेशा कैंटिलीवर के केस में हम फ्री एंड से शुरू करेंगे. Either we want to draw the shear force diagram or bending moment diagram, whatever be, but we start from free end only. So we want to draw the shear force diagram. This is, we take the section at A, we start from free end at B, section is this at A, section right side downward, right side downward, means shear force would be negative. This is section, at A. Load is right side, it is downward, so it would be taken as negative W. We come down by W, नीचे आ गए W से, W मैग्नीट्यूड के साथ हम B पॉइंट से नीचे आ गए. अब क्या है, there is no load between A and B or from B to A, so line would be parallel of zero line AB because there is no load, so line would be parallel to AB up to A, then we have taken the section at A. RB is upward, right side of all the forces would be taken as either the right side or left side. This is the definition of shear force. So we take the RA as right side. So RA at section A, RA is section, this is section. If load is upward, RA is upward, so it would be taken as positive. So from this point, we go upward by the magnitude of RA. And what is the magnitude? What is the value of RA? RA is equal to capital W. So we would go upward by capital W, and by going with load W, capital W, we will reach at point B. So it will close at point B. This is shear force diagram negative. From B we come down. So this would be negative shear force according to our sign convention. This is shear force diagram. A, B, this, and this. Now come to the bending moment diagram. Bending moment diagram. This is fixed support, and we have already understood that at fixed support, MA moment at A, moment at fixed support would never be equal to 0. It has always certain value if the load is supported by the beam. MB is 0 because it is free. Moment at B is 0 because it is free. Now, to calculate the moment at different points, we take a section at distance x. X is variable, so we take a distance x, a section. So value of mx, moment at a distance x from B, we always start from free end. In the case of cantilever, mx is equal to w into this distance where we have taken the section, and it is from x distance. So w moment would be equal to load into perpendicular distance. This is x, w into x. After that, between this section and B, there is no any load, so mx, the value of mx will be equal to w into x. Now we put the value of x, different values of x, and we get the different moment at different points. From from B, if we want to know the moment at a distance L by 4, 1/4 of this distance, L by 4, the moment would be WL by 4. when the x is L by 2, means we want to calculate the midpoint, we want to calculate the moment at midpoint of beam, that would be equal to WL by 2, WX, x की वैल्यू रख दी हमने L by 2, WL by 2. When we want to calculate the moment at A, this is fixed support, when x is equal to L, that will give us the moment at A, MA. This would be equal to MA, W into L. This is the maximum value of bending moment, and that would be at support, fixed support at A, WL. So we take the points here, WL by 4, then here WL by 2, and then here WL, and when we join this line, this will go like this in upward, and this is the shear bending moment diagram. This is bending moment diagram, triangular section. This is bending moment diagram. M is the maximum bending moment, maximum moment at the fixed support. Moment or bending moment, both are same thing. We can write bending moment also, or moment. No, it makes no difference. So BMD, bending moment diagram. Bending moment diagram. This is the shear force diagram and bending moment diagram of a cantilever beam subjected to a point load at free end B, and that magnitude of load is capital. That's all. Thank you.